Welcome. Yes, I teach 8 a.m. classes on Monday, Wednesday, and Tuesday, Thursday. Some days, this is what I have when I start. The students haven't quite got there on Monday morning. Yeah, they're not happy, but our industrial advisory board, they say you need to teach 8 a.m. classes. We want students ready to work when they get out. And where it impacts is their GPA, because there's a number of the test questions that come from what I say in lectures. So if you're not there, I give the answer. If you're there, you get it. And if you're not there, your grade suffers, your GPA suffers. So GPA is a good tool to use for assessing maturity of students. And so this is the way they have us teaching. And so it's fun that way. Today, what I want to share with you is the realm of quality. This is one of the lectures I do in our quality assurance class, the fundamental tools of quality. But it applies to anything. It came out of the manufacturing world. It's data intensive, data centric, but it also will apply to the world of IT, building the data itself. What are the tools you use to assess the quality of the data in the database? It's no different than assessing the quality of the products coming off of the assembly line. Sometimes I talk about the data factory to my students. Let me get this plugged in.
Did you put the thing?
The dongle.
Yeah. Here, push the end of it.
There it is. I know I needed something. There we go. This is a slide that I showed yesterday of focusing on the engineering role. I enjoyed Raja's talk. He talked in the realm of the data scientist, the transaction processing. I'm glad he went after me. He had interesting stuff, but that's over in what's now being considered classic data science. As I said, I teach engineers. They need to understand the skills of data science and how to apply it. And so what do I mean by the skills of data science? Well, I drew up this dodecahedron to identify what I teach in the engineering data analysis class and my graduate level data analytics class. Teach at different levels, but the same concepts. The first concept, data modeling and database management. If you can't read the blueprint, you have no success. You have zero chance of success of working with your using data to solve a problem, whether it be quality, whether it be scheduling. But you got to know how the data is stored in there, what your conceptual model is, the logical model, the physical model, where are things stored. Especially if you're designing to put a new machine on and you want it to talk and be the data absorbed into the matrix, what I call. You need to understand how the system's already built. And so once I show the students the blueprints and they can read them, they go, oh yeah, this is no problem. This is easier than circuits class was. Because they're used to building circuits. They understand how to read those diagrams. That's what gives me an advantage in how quick I can teach versus what Raja has to teach for his data scientist. My students intrinsically know units of measurement, how they have to be aligned. You always have to look at them. That's burned in. They've been through circuits and statics. They can work very large, complicated problems with many moving parts. If they didn't get through those classes, they're not in my class. So I know they have those skills. So in many ways, it's very easy for me to teach these skills quickly at a high level. What do you need to know? You're not an expert. You're not going to go build the database, but you need to work on it. You're the driver in the seat. You're going to be a power user, is what I've been called many times in my career by the folks in IT. And I always had a good rapport with them because I don't want to do what they do. I don't want to update your database. I don't want to do the backups. I don't want to worry about computer security. So however you tell me it needs to run, I'll run it. I'm not going to be a rebel. I don't want to do your job. I appreciate what you do. The second skill, extraction, transformation, and loading. And so this is the heart. How do you get data from the database into something that you can use? The main tool that we teach our students is Excel, because you can download through Power Pivot, you can reach into a database, use VLOOKUPs for transformations, what I call the meditation of 10,000 mouse clicks. When you get in and have to change, you have data coming from 3 systems, they each use a different date format. Which one do you go to? And you just, yes, you can go through, build some app, ingest it, transform it, put it back out. But if you only have 200 rows, sometimes it's quicker just to do it. Just go click, click, pound it out, and you're done. And you're off and going for a quick answer. The heart is data mining and descriptive statistics. I will show a little bit of descriptive statistics. The tool that I use, that we teach, is JUMP, JMP from SAS. I'll do a demo. It is a very handy to use package. Visualization. How do you get the information transmitted from what you have to management? Inferential statistics, and then, which I do not teach in our engineering data analysis class, and then the modeling, both predictive and prescriptive. And I'm using Davenport's terms for analytics, the 3 legs to the analytics stool: descriptive, predictive, and prescriptive. But they take entire classes on optimization, entire classes on building simulation models to predict. And so we do a lot of that in industrial engineering. So I don't cover that. But they need to understand, where's the data coming from? How do I work with the data so that I can do the higher end differential statistics and modeling activities? And so it makes it easy to teach. I focus on the nuggets. I do it very quickly. We get them up to speed, just like we teach engineering economic analysis, the time value of money. That class hasn't changed since the 40s. I don't know. And every engineer takes it. So that's what we're trying to figure out. What are the universal skills that every engineer at our university needs to be successful in the 2025 workplace? That is just a big question that's out there. And then this one I didn't show, but this is my view. I'm going to talk about my book, Quantitative Analysis.